10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and 0. And the liftoff of the Falcon 9 rocket and the Dragon spacecraft, packed with science and supplies for the International Space Station, humanity's home in low Earth orbit. And Falcon 9 has cleared the tower. SpaceX ASIM commentaries performed by several people. The propulsion engineer calls out propulsion events. The avionics engineer calls out avionics health and Dragon separation. The range coordinator calls Air Force satellite control network acquisition and loss of signal. And the ground station specialist calls out the SpaceX antenna acquisition and loss of signal. Seconds after liftoff, the Falcon 9 will reach transonic limits. The vehicle will pass through an area of maximum aerodynamic pressure called maximum. And within 18 seconds after liftoff, this is the point where the mechanical stress of the rocket reaches its peak because of the rocket's velocity and resistance created by Earth's atmosphere. Supersonic. Supersonic.
Vehicle is experiencing maximum dynamic pressure.
Confirmation of max Q. One minute and 30 seconds. Second stage engine chill has begun. Around 2 minutes 35 seconds into flight, the 9 Merlin engines will sequentially shut down. You'll hear the term MECO, which means main engine cutoff.
Main engine cutoff on the first stage. Stage separation confirmed. Second engine start warning. The Merlin vacuum engine has ignited. The first stage is now performing experimental entry and attitude control maneuvers to gather. Flight data, no landing. Attempted a second stage trajectory remains perfectly nominal fairing separation confirmed. The second stage is completing its burn to orbit. Spacecraft separation in 3, 2, 1. Dragon has separated cleanly and is now flying free both. Solar arrays deployed. Rays fully extended and locked. Dragon is generating full power and in excellent health. With Dragon safely in orbit. The focus now turns to rendezvous operations with the International Space Station. Orbiting 250 miles above Earth, series of precise phasing burns will bring Dragon to the station over the next 48 hours. Approach sequence initiated. All parameters nominal. Dragon now entering the keep-out sphere and holding at waypoints. The spacecraft is in free drift for final capture. CANADARM-2, operated by the expedition crew. Has successfully grappled Dragon. Capture confirmed. Dragon is securely held. 48 hours after launch, Dragon is now closing in on the International Space Station. Orbiting 250 miles above Earth *, a series of precise phasing burns have aligned the spacecraft peak. Perfectly for today's rendezvous *. Approach sequence is underway. All navigation and ranging data are nominal as Dragon passes through the predefined waypoints. The spacecraft is now inside the keep-out sphere and holding steadily *. Dragon has transitioned to free drift in preparation. For capture, on board the station, the expedition crew is operating the 57-foot Canadarm to robotic arm. The arm is extending, aligning, and grapple confirmed. Canadarm has successfully captured Dragon. The spacecraft is now firmly in the arm's grasp and will soon be berthed to the Harmony node. Another precise and flawless rendezvous for the SpaceX Dragon fleet. With Dragon securely berthed to the Harmony node, the expedition crew begins the process of transferring cargo and scientific payloads. *1 of the key experiments on this mission is the Materials International Space Station experiment. Flight Facility, or MISSE-FF, is a permanent external platform designed to test how various materials withstand the harsh environment of space, including extreme temperatures, atomic oxygen, ultraviolet radiation, and micrometeoroid impacts. *300 materials samples are contained in sample carriers that will be exposed directly to the space environment. Using the station's canadarm and the special-purpose dexterous manipulator, known as Dexter, the MISSE-FF facility is carefully removed from Dragon's trunk and transferred to its mounting location on the Express Logistics carrier. Robotic operations ensure precise alignment in the weightless environment. Installation complete. MISSE-FF is now fully deployed and powered, beginning its long-duration exposure testing. Data from these experiments will help engineers develop more durable materials for future spacecraft, satellites, and even deep space missions. Another major external payload on CRS-14 is the European Space Agency's Atmosphere-Space Interactions Monitor, ASIM. Using the station's robotic arms. ASIM is now being installed on the exterior of the Columbus module. This advanced observatory will study high-altitude electrical discharges above thunderstorms, including spectacular upper atmospheric lightning and powerful terrestrial gamma-ray flashes. One of the most innovative payloads delivered by CRS-14 is RemoveDEBRIS, the world's first in-orbit demonstration of active debris removal technologies. Led by the Surrey Space Center and sponsored by the European Commission * during the mission, RemoveDEBRIS successfully deploys a net to capture a small target CubeSat released from the platform itself. * The net envelops and secures the target, demonstrating a low-cost method to capture and detumble uncooperative space debris. Next, a harpoon is fired into a target plate extended from the spacecraft. The tethered harpoon penetrates and locks onto the panel, proving another viable technique for capturing larger, non-cooperative objects in orbit. Finally, RemoveDEBRIS unfurls a large drag sail to increase atmospheric drag. This accelerates orbital decay, ensuring the platform safely burns upon re-entry, a critical end-of-life deorbiting solution for future satellites. These groundbreaking demonstrations mark an important step toward cleaning up Earth's crowded orbital environment. After nearly a month's dock to the International Space Station, Dragon is loaded with over 4,000 pounds of valuable scientific results and hardware for return to Earth. One of the most notable items returning is NASA's Robonaut 2, the humanoid robot assistant that has operated on the station for years. It is being sent home for repair and upgrade after developing an electrical issue. Also aboard are critical biological samples, including those from the European Space Agency's in vitro bone experiment studying bone cells in microgravity and blood, samples from the marrow investigation into the effects of spaceflight on bone marrow and blood production. Additional return cargo includes results from student-designed DNA experiments and genes in space program, various microbiology, materials research samples, outdated equipment for analysis or refurbishment, and waste materials from the Expedition 55 and 56 cruise. Dragon undocks, performs a deorbit burn, and re-enters the atmosphere. Parachutes deployed, and the spacecraft splashes down safely in the Pacific Ocean, completing another successful CRS-14 mission.